So this is the graphing and data table practice workshop. And I know that this is something that usually I see students struggling with to remember exactly how to make graphs, which one's the x-axis, which one's the y-axis. How do I make it on the computer? Most of us can draw it, but making it on the computer is another thing. So I think it's an important skill to have and to be able to do, especially moving forward in future science classes. And we're going to write a lab report in this class as well. So please follow along. And if you can kind of listen to me and try to do it as I do it, or, practice and then share it with me. If you're virtual, then that would be a great thing so that I can help you out with that and give you feedback. So why do we use data tables? So we use data tables to be able to show trends in information that we're sharing in the data that we have collected. It allows us to compare results, to see maybe a majority, to see trends, to see things over a span of time, over different temperatures, lots of different things. So we use data tables to organize the information, and then we use graphs to be able to show that and then to be able to analyze that data. So what types of graphs are there? So there are line graphs, which is the one that is first shown right here. And then we have bar graphs, which is in the next box over here. And so here, so we have our line graphs here, and then we have pie charts here next, and then finally we have our scatter plots here, which scatter plots are mainly to look at trends. So you look at where things are most clumped together. So this is pretty spread out, but kind of here in this middle region is where a lot of the dots are at, and that's how we can look at trends. Okay, so let's go to our next slide. Okay, so we're going to practice making a data table. So Elodea is a water plant that releases oxygen when it conducts photosynthesis. It is an important oxygenator within aquatic ecosystems. A scientist wants to test the rate of photosynthesis by placing one plant in a very sunny location and another in a dimly lit location. He records the amount of bubbles every 10 minutes for 60 minutes. So the data for the sun and the data for the shade. So we're looking at time versus amount of bubbles being produced. So we want to make sure when we are making a data table and then a graph is that there's a title and that you number it. So if it's the first one that you're making, it would be number 1. And you want to figure out how you want to organize the information so it makes sense into rows and columns. A lot of times, if you put what needs to be on the x-axis on the horizontal and what needs to be on the y-axis on the vertical, then that will allow you to copy and paste that and directly make a graph from that information. And then your units of measure should not be included in your column headings. It should be included in the column headings, but not in your individual cells. So those should be in parentheses after the title of your headings, and that will make sense here in just one moment. Let me check my email. Okay, I just want to make sure no one was, trying to join a meeting I was having. So let's try this and look at this electronically and try to make this data table and graph. So all right, so first we need to make a data table. So let's go back and look at the information that we know. We know that he is recording it every 10 minutes for 60 minutes. So that means there are 1, 2, 3, 4, 5, 6, 10, 7 different data points, right? So 10, 20, 30, 40, 50, 60, but then we also have the 0 time as well because we always want a starting point. And then we know we need to add one more um, column because of needing the title for that. So what we're going to do is we're going to insert a table that is 8 by 3. Okay, and we know that it needs to be 3 rows because we know that there's two different experimental groups here, sun and shade, but we know we need a title for that, and so we need to add a third one. All right, so what we're going to do is here, we're going to put our time across. So we're going to put 0, 10 minutes, 20 minutes, 30 minutes. And then here, we're going to put sun and shade. Okay, and then next, we're just going to transfer all this data over. So 0, 15, 25, 32. And the shade data. Okay, now that's fine and dandy, but it doesn't look very nice. So that's part of making these is to make them look professional. So you're going to, I always like to center it that way. And then I also like to bold the like headings or the titles of each row and column so that it looks nice and organized like that. Now, what do I need to do? I need to title it. So this is table 1, Elodia response over 60 minutes to sun versus shade. And a lot of times with this, I also like to bold that as well so it looks nice and it stands out. So see how lovely that looks? Now we need to take this information and we need to put it into a graph so that it can graph this information so we can interpret it. So we're going to go to insert and we're going to insert a chart. And for this one, I'm going to use a line chart. I like using line charts. Okay, so in Google Docs, when you're doing this, you click on this little arrow, and you go open source. So that's going to then open a Google Sheet for us to be able to put our information in. Okay, so this is where it's important to know what information needs to go on the x-axis and what information needs to go on the y-axis. So let's go back and look at our information. So we know that they're recording it every 10 minutes for 60 minutes and that they're collecting the amount of bubbles depending on the amount of light, whether or not it has light. So we know our independent variable is always going to be the thing that is not manipulated in any way or changed. It is just a factor that is present. And this sometimes is what the experimenter controls. So he's controlling the amount of time. So the time should be on the x-axis. And then the amount of light depends. So it's the dependent variable. So the amount of bubbles that are produced is the dependent variable. And that is going to go on the y-axis. Okay, so time is on the x-axis, amount of bubbles produced is on the y-axis. Okay, so if we look here at this and you're like, well, shoot, like I don't know like how to put this into this Excel spreadsheet. I don't know what to do. Well, just look at what they've given you. So if you see on the bottom, team 1, 2, 3, and 4, that is information that's on the x-axis. That means that this information here is where you're going to put your times. So we're going to put 0. You might have to drag that little blue arrow down so that it encompasses all of that. Okay. So then period one, these are different data sets here, period one and period two. As you can see over here, they're two different colored lines. So we have one data set that is all of our sun information. And then we have all of our information that is for shade data. Okay. So you can delete this and we can put in our new information. So sun and this is kind of tedious. Unfortunately, you have to just kind of copy and paste it, but it doesn't take very long. And then we go and get our shade data. Okay, now, as you can see, it graphed the two different lines. And now we can use that to look at and interpret our data. So we do need to do a few things to this to make it look like it should, because every chart needs to have a title and the axes labeled. Okay, so we're going to, you click on these three dots and you go to edit chart. Here, you have all the things that you can edit. And so what we're going to do is customize, and you can change what it looks like. So if you're real particular, like, ooh, I want the background to be gray, I want the chart border to be green, since we're talking about a plant, and we want it to have a smooth line, and we want the axis titles and the chart title. So we want the chart title first to be Elodea bubbles produced in sun versus shade. Okay. And then the text color you can change as well if you want to make that green, and then maybe center it so it looks nice on there. Then we need to label the axes. So the horizontal axis title is going to be time in minutes. Okay. And then the vertical axis axis title is going to be number of bubbles produced. Okay. And then there you go, you have your data. So then your series are the two different lines. So you can change the series. So if you want the sun data to be orange to represent the sun, and then you want the shade data to be like a darker gray to represent shade, you can do that as well. But that's totally up to you. But at the very least, you have to have the axes labeled and a title on the graph so that we all kind of understand what's going on. So now when you go back to your Google Doc, if you hit update, it updates the graph, and now it looks like a very nice graph. Graphs also need titles. So we would title this graph 1, Elodea bubbles produced in sun versus shade. We're going to bold that as well. So that is how we graph in Google Docs or in Excel. Okay. Um, and so, like I said, we want to make sure that we are understanding how to do this and doing a really nice job of making these data tables look nice. And I just realized I must have deleted this data accidentally. Let's fix that 0587. 1099. Yes. So this is the basics on how to make this. Let's go back to our presentation now. Okay, so I kind of talked through all of this, but just as a reminder, as you're looking through this presentation is linked as well within this workshop page on Canvas. So just remember, you always have to have a title and a number for it. You have to have a legend, um, which is like where it says this color of line is for sun, this color of line is for shade. Axes are labeled, they're scaled appropriately, so it makes sense. And then make sure you have the independent and dependent variable on the correct axis. And then you're able to identify those. That's a really important skill as well. The last thing I want to cover is just units of measure. So we have lots of different units. So there's the metric system, and then there's the imperial or US standard system. So most of the world uses the metric system, and it's all based in unit of 10. So basically just moving your decimal point one place to the right or left every time you move up a unit of measure. Um, Sometimes you move it more or less depending on what the unit is. So the standard unit of length is always meter. Area is usually like meters squared or centimeters squared. Capacity is liter or milliliter. Volume is um, centimeters cubed or meters cubed. The standard unit of mass is gram, kilogram, or ton. Time is minute, second, or hour, and then temperature is degrees Celsius. So then you can see in the imperial system that it's different and it's more confusing because there's so many conversion units that you have to remember. But in the metric system, which is typically what's used in science, it is very easy. It uses prefixes. So if we're looking here at this table on the right-hand side, the prefixes are on this column right here. So this exa, peta, tera, giga, mega, kilo, hecto, deca, deci, centi, milli, macro, micro, nano. Okay. So this one that is right here in the middle, this one, this is um, this is where we start at our base unit. Okay. So when we're saying I have 1 gram of a substance, that's where we're starting at, is right here. And so this is where we always start out with if we're converting something. So then if I say, I want to go from, I want to see how many um, milligrams are in a gram, right? Okay, so milli is less. Okay, milli means there's less. So it says that it is, sorry about that it is 1,000th as big as that. So that means that there are 1,000 milligrams in 1 gram. Okay, so it's kind of counterintuitive. So basically, what it is when you start out with the unit that you want, you say 1 gram, and I want to get to milligrams. So I multiply this by, okay, so how many grams are in a milligram? Okay, so it tells you here there's 0.001. So 0.001 milligrams. I'm sorry, I did that on the wrong side. Hold on. Let's do this again. There are 0.001 grams in 1 milligram. Okay, so essentially here, your grams cancel out, and if you use a calculator, which I'm doing on my phone right now, if I swear, these phones sometimes, if you use a calculator, and you take 1 and divide it by 0.001, you get 1,000, and that's your answer. Okay, so you always start with the unit you have, and then you try to cancel it out, and you just use the numbers on this chart. So let's try another one going the opposite direction. So if I have 900 grams, and I want to find out, okay, so if I have 900 grams, and I want to find out how many megagrams is in 900 grams. Okay, so I want to go to this unit here. Okay, so I know that there are 1 million grams in 1 megagram. So my grams cancel. Okay, and then we take 900 divided by 1 million. And you're going to get 0.009 megagrams. Okay, so I know it seems confusing, but you will get the hang of it. You basically are just moving the decimal point. Okay, so then you can go opposite directions too and go back and forth, but that's more for once you get to chemistry. I just wanted to introduce you to this. So let's look at a few examples here other than what I did. So 3.5 kilometers is how many meters? Okay, so let's try doing this. Let me get my annotate tool out here. Okay, so if we have 3.5 kilometers, okay, now we need kilometers to cancel, so we need kilometers on the bottom, and we need meters on the top to get our answer. All right, okay, so we have 3.5 kilometers times, and we know on the top that we need meters over how for many kilometers. Okay, so let's look at this. So we know kilometers here is a bigger unit. So we know that there are 1,000 meters in 1 kilometer. So we would put 1,000 on the top, 1,000 meters over oh my gosh, guys. Sorry. Okay, 3. Anyways, that we know that there are 1,000 meters in 1 kilometer. Okay, and then these cancel. So then we multiply that. So that's 1,000 times this. So that's 3 places to the right. So if you do the math on the calculator, that is 3,500 meters. Okay, so then next is 40 liters is how many milliliters? So we start with 40 liters. We know that we need to cancel our liters, so that's going to be on the bottom. And we know that we need megaliters on the top. Okay, so let's look for megaliters. We know that there are 1 million liters in a megaliter. So down here we have 1 million. Liters. So then we take 40 divided by 1 million. And so we have 0.0004 is our answer. 0.0004. Okay, now try these next two and I'll just give you the answer and so you see if you're right. So 5.5 grams to micrograms. So this is 5.5 million. I just didn't want to write all the zeros. 5.5 million micrograms. Then we have 2.5 teragrams. How many grams is that? This is 2.5 times 10 to the negative 11, which basically means that if you move the decimal point 11 places to the left, then that's where the zero is at, or the decimal point is at. And there's that many zeros. There's 10 zeros. So I know it can be a little confusing, but I just at least wanted to introduce you to it. All right. So you do have some independent practice with this. And so that independent practice is on Canvas, linked to an assignment called Graphing Practice. So you can use this to kind of help you understand how to graph and also do some conversions. And this is due on Friday, August 20th.